Welcome to the demo for Motor Control Basics Shop Job Demo. Here we're going to take a look at the parts to a control diagram, and this should also be a review from the two previous PowerPoints. The first thing we're going to take a look at is the power circuit, then the control transformer, control circuit protection. We use a circuit breaker in shop class, X1 to X2 power rails that give us 120 volts. And then we're going to get into the rungs where the buttons, contacts, and loads are connected, the rung labeling and the wire labeling, as well as cross-referencing for coils. So the first portion of our control circuit, the power circuit, we come from our disconnect, which is right here on the left-hand side. So we have a fuse disconnect. Our disconnect has line 1, line 2, and line 3 coming through it at 120/208. We take that and go to our primary side of our control transformer. From the disconnect, we also go to the line side of a magnetic motor starter. So again, this should be a bit of a review for you. So this would be the top side of the magnetic motor starter where you bring line 1, line 2, and line 3. Those are the power contacts for the magnetic motor starter. And then right here would be representing the overload heaters or the overload protection for the motor itself. And then on the load side of the motor starter, we see where the actual motor is connected. On the secondary side of the control transformer, we form an X1 and an X2 at 120 volts. Right here we have a 3 amp fuse, and then we form our X1 and X2 power rails that you'll see in the next slide. So those two power rails come down as X1 here and X2 on this side. You'll notice that we put our switch first. So right here we're using a limit switch, a normally open limit switch. When we close that limit switch, we're going to send power to the M coil. This is the control coil. That will go through the overload relay contact and back to X2, supplying the motor starter with 120 volts to engage the motor. On the second rung, which is number 2 on the left-hand side, identifying the second rung, you see this is wire 1 as well. Well, that's because electrically it is the same as the previously labeled number 1 wire. After that, we have a brand new wire labeled number 5. That is electrically different than any other wire that is currently installed. The other thing that we should notice here is that the M coil is being cross-referenced that it has an open contact on rung number 2. So this coil is controlling this contact and it is placed on rung number 2. When this motor coil is energized from the switch that is in front of it closing, the M contact will close down here. This is an auxiliary contact. Once that closes, then the red light will come on, indicating that the motor is running. That would be our 2-wire control. 3-wire control, we use 2 momentary push buttons. The stop button is a normally closed momentary push button, and the start button is a normally open momentary push button. If I wanted to have more than one stop button, I would have to wire them all in series prior to the start button. If I wanted multiple start buttons, they would have to come down and all be in parallel with each other after the stop buttons. What we're seeing right here is a holding contact. Again, that is being controlled by the M coil, and once the coil is energized, this contact will close, and that will actually be the path for current to flow to allow the motor coil to stay engaged and continue to run. Further down, we see 2 more auxiliary contacts, one normally open and one normally closed. Both of those are also referenced by being controlled from this coil on rung number 1. Here we have one on rung 2, one on rung 3. Those are both normally open. And then the one on rung 4, the underline indicates that it is a normally closed contact. So when this coil is energized, this contact will open, the green light will go off. With that coil energized, this contact will close and the red light will go on. Notice again how the rungs get labeled 1, 2, 3, and 4. All of the wires that are electrically the same get the same number on the beginning as well as on the end after the overload. You see how here's 5, this one is also 5, and that one is also 5. Thanks for watching.